In this video I am going to begin with the problem 8, and I am going to show you this problem. It might look quite simple, but there are many possibilities of going wrong, or like completely diverging from the problem. So I am going to show you how. So the first thing, if I start with LHS, is simplifying. I will take the expand using the formula a plus b whole square is equal to, so if I write a plus b whole square is equal to a square plus b square plus 2ab. So if I write it, so I can interchange it, 2ab in between or b square, that doesn't matter for time being. So using this identity I can continue I can expand that sine square a plus cosec square a plus 2 sine a cosecant of a plus, again I am going to use it, plus cos square a plus secant square a plus 2 into cos a into sec a. So now I have a reason why I directly expanded without writing in terms of sine or cos, because already the terms exist. So now if I try to simplify it, you may know that sine a into cosec a is nothing but 1 by sine a. Cosec of a is 1 by sine a, so this will be 1. So 2 into this one will be equal to 2. So I can write this. Similarly, cos a into sec a is also 1. And also using the identity sine square a plus cos square a is equal to 1. So I can equate these terms, add these two. So and this this is 1. Use a different marker. So this is 1, this is also 1, so 2 into 1, this whole thing, so 2 into 1, and this one is 1. So remaining terms I can write like this. So let me start with cosecant square a. I'll use the black ink. So now the remaining terms are cosecant square a plus secant square a plus 1 plus 2 plus 2. So we have got the 5 here, and also we have got the secant and cosecant. So now what to do next? So let's see how to simplify this further. If I write this in terms of, now if I use 1 plus tan square is equal to 1 plus tan square a. This question is tricky because you need to know all the three identities to solve this question. So tan square a, 1 plus tan square a is equal to secant square a. And also I can use one more identity, 1 plus cosecant square a, 1 plus cot square a (1 plus cot square a), just a slip of tongue, 1 plus cot square a is equal to cosecant square a. So this three identities, if I use this instead of secant theta, because I need tan and cot, but here we have only sec and cosec. So I can directly write 1 plus tan square a is equal to secant square a, and also let me substitute it. Cosecant square can be written as 1 plus cot square a plus 1 plus tan square a, and now plus 5, 2 plus 2 plus 1 is 5. So this bracket is just to show that I am substituting this instead of this one, so no need to use the bracket in this case. So 1 plus 1 plus 5, 7. So the 7 which was in the RHS, we got the 7. Similarly, plus tan square, we have got it, and remaining term is plus cot square a. So this is what is equal to RHS. This seemingly simple problem, but there was a chance. I will give you a task if it is possible. Try to start by substituting cosecant a is equal to 1 by cos. Yeah, try to start by using cosecant a is equal to 1 by sin a, and sec a is 1 by cos a, and simplify it and try to get the answer. If you started this way, there was a more chance that you might have done an error. So let me show how. This is the problem, this is the end of the problem, but I want to show that what are the possible mistakes here. So let me if I take sin a plus 1 by sin a whole square. So this is nothing but, I can write this as sin square a plus 2, directly sin a into sin a. I am doing it faster, so here I don't want to take more time. Sin square a plus, again similarly, if I expand, cos a plus cos square a plus 2 plus 1 by cos square a. So now if I try to take LCM, because you may think we need tan square is 1 by cos, sin by cos square, so cos square is there in the denominator and sin square is there, so you may get, suppose the smarter person would have been he, if he or she would have been found out that this is equal to 1, and we need to put 1 by sin square of a is equal to 1 by sin square of a is equal to cosecant square of a, and 1 by cos square is equal to secant square of a. So if it have been put in this way, then after this there was, you will go directly reach to this step. So but what happens if one tries to, instead of doing that way, one tries to find the LCM, take the LCM and proceed. So what will happen? This will be plus sign. So let me just say that he have noticed the identity sin square a plus cos square a. So let me take 5 as outside. Also I can multiply, so remaining terms are 1 by sin square a plus 1 by cos square a. So now I can write sin square 5 sin square a cos square a plus 1 plus cos square a plus sin square a divided by sin square into cos square. So now just think the existence, again I will use this identity to simplify it. So I will get 1 plus 1 plus, if I use it, then I will get 1 plus 5 sin square a cos square a by sin square a. So now there is no way that one can try to simplify this problem here. So you are stuck in a loop, I can say. You may simplify from here, but there is no way that you can end up getting the result sooner than expected. So there are possibilities of going wrong. So I am pointing out that what are the other possibilities of solving the problem and also other ways which you should not solve a problem. So with this I am going to end this. So it is up to you that someone, if someone finds the answer by using this method, this from here can comment it below. I am not concerned because I want to only point that what happens if you do in this way and that way. There are, as I said earlier, there are multiple ways to solve a same problem. So multiple ways to approach the problem. So it is not wrong. It is good to learn from the experience. So I will start the next problem. We have learnt enough in this problem. We have analyzed it. So question number 9. The question is cosec minus cosec of a minus sine of a into sec of a minus cos of a minus cos of a is equal to 1 by tan a plus cot a. So this question, one might think that this is little bit tougher, or by seeing perhaps, but I am going to start with LHS. LHS is equivalent to, I will start again by taking this time I will use a completely different method. I will start as in the previous method. I told that no need to take simplify in terms of sine and cos. Now I am taking a U-turn here. I will start by substituting cosec as 1 by sine a minus sine a. So this becomes into 1 by cos a minus cos a. So what is this one? So if I simplify this 1 minus, so you will get 1 minus sine square LCM. If I take a sine square a divided by sine a into 1 minus cos square a by cos a. So now this problem, this might look now it might be very simple from here on, because this was the first step here was very important, because now I will simplify it. I can write, sorry, it should be sine square a sine square a is equal to 1 minus cos square a, and I will substitute this result. Cos square a is equal to 1 minus sine square a. So if I use this, now I will get 1 minus sine square a is nothing but cos square a by sine a into sine into 1 minus cos square a is sine square a by cos a. So now you can see there's a power here. It can be this is a form, for example, I'll take x square by y into y square by x. So this is equivalent to, you know that square term will go and here 1 and square term will go, so remaining term is xy. So similarly I can write like this: sin a, so sin a into cos a. So this is a method to solve the question here. So now this one LHS I have simplified it. So now we have not got the RHS. So RHS I will try to simplify it. So 1 by sin A by cos A plus cos A by sin A. If I take LCM, sin square A 1 by sin square A plus cos square A by 1 by sin square. So if I take LCM, cos square will get multiplied sin square into sin A cos A. So this identity again, this is 1. So 1 by 1 divided by 1 by sin A cos A. So this is nothing but sin A into cos A. So RHS is equal to LHS. So which is equal to LHS. So I have solved this problem now. With this I have completed this problem.